Alrighty, good afternoon, everyone. I'm Heather Sparks and am the manager for grants and engagement at the Geological Survey of Queensland. And today I'm excited to give you an update on a couple of initiatives that the Geological Survey of Queensland is running and touch on some other funding programs that you might not be aware of, but you could possibly be eligible to apply for. So we know that without a prosperous, active, and vibrant mineral exploration industry, there are no future discoveries. And it is the discovery of copper and other base metals that keep the minerals sector alive and feed downstream industries, some of which are becoming more and more important as the world decarbonizes. So what's the current state of play? I recently saw this presentation by Richard from Minix Consulting, and I thought he had some really great statistics I wanted to share with you, as I think it paints a pretty interesting picture. So the colored stacked bars represent the number of discoveries made by different regions over time. Australia is represented by the pretty dark blue squares at the bottom. And we can see that from 1975 to 2022, discoveries have undulated over time. But the recent global trend is that the number of discoveries is declining. Australia, down there in the dark blue, makes up about 18% of all the global discoveries from the 2012 peak to 2021. We also see this being reflected in the number of drilling results being announced. There was a drop of about 25% fewer drilling results announced in 2024 than in 2022. And as we know and pointed out by Oztech, without drilling, there are no discoveries. So what do we know about exploration expenditure in Australia? This plot is taken from the Bureau of Statistics, and it plots the Australian mineral exploration expenditure over time from pre-2000s to present day. And as you can see, there have been a number of booms and busts. This top line, that's sort of hard to see, sorry about that, it really emphasizes those peaks and troughs, and that's over in Western Australia. However, Queensland is here in the orange line, so let's just zoom in and get a better idea of what's happening in Queensland. Okay, so this is just the plot of Queensland's mineral exploration expenditure. Although over the past few years we were trending up, you can see now there is a sharp spike downwards. This sharp decline over the last 12 months equates to about just over a 6% drop in exploration expenditure in Queensland. So it's not all doom and gloom. This is a screenshot from LinkedIn from Paul Holden, who spoke earlier today, and he noted that last year mining was the largest industry, bringing in a whopping $86 billion. So why is all this important? And why is the Queensland Government putting forward so many funding programs? Queensland Government has set some very ambitious climate targets. We are committing to having 50% renewable energy by 2030, a 30% emissions reduction below our 2005 levels by 2030, and net zero emissions by 2050. There is going to be both challenges and opportunities for both the government and the resources industry. I mean, how many projects do we need to achieve our net zero targets? I saw this post also on LinkedIn recently, and I thought it captured the concept pretty accurately. I think it says two things. Firstly, it's complicated. And secondly, we aren't going to get there alone. So, what are some of the awesome funding initiatives on offer? As a bit of a background, the Queensland Government has been running this merit-based reimbursement program in one form or another since 2007. It used to be called the Collaborative Drilling Initiative, so only drilling programs were eligible. This was a way for the department to collect drill core as a public resource that people could come and view and do research on. In 2017, it expanded to include more activities than just drilling, and it became called the Collaborative Exploration Initiative, or CEI. So far, the initiative has supported over 275 programs. Now, CEI only has funding for 2 more rounds, but each round is going to be funded with $5 million each. Now, round 8 is currently running, and it is supporting 18 projects from 16 different companies. This round, the maximum funding proposal you could apply for was $300,000. And I think that's why we see far fewer companies this round being supported than we did in round 7, where the maximum was far less. But as you can see on the map, we have sort of a good focus on the Mount Isa region this year. The data collected under this round will be made publicly available in June 2025. So you might ask, are there any success stories out of CEI? And I will tell you, yes, there are plenty. But the one I'm going to focus on today is Graphinex. And I was fortunate enough to meet with them earlier this week and have a look at some of their drill core. So they were successfully awarded a CEI in round 8 to drill 1 deep hole. This maiden CEI funded hole confirmed the presence of a thick graphite mineralization. This one CEI funded hole led the company now to drill a further 10 holes and confirm the presence of a significant graphite mineralized zone. So yes, there are plenty of success stories out there. So you might be wondering, when is round 9 guideline going to be published? Well, this year we're going to open the round next month. Yes, you heard me correctly, in late September. We're going to publish the guideline so it doesn't clash with the upcoming election. We are going to close the round for applications in December, so you'll have a pretty lengthy period of which to prepare your applications. This year, there will be a strong focus on genuine critical mineral exploration. Queensland has set 0 carbon emission targets, so to meet these targets, we need critical minerals to get us there. We'll continue to open up all of Queensland for exploration, and therefore all parts of the state will be weighted equally. And finally, you will be expected to address QRIDP's focus areas and how your company is supporting Queensland's climate change targets. Now, before you begin to prepare your application, please ensure you meet the eligibility criteria. Applicants need to hold tenure in Queensland. You will need to provide evidence that your company has public liability insurance for a minimum of $10 million. You will need to have an Australian business number and be registered for GST. Contractors' letters of support will need to be provided. This is to confirm that applicants can meet the timeframes of CEI. So, for example, please supply a letter from the drilling company to confirm rig availability. As CEI is a reimbursement initiative, you will need to be able to financially undertake your activity. Extensions to the timeframes will not be considered. All tenure, including tenure held by associated entities, must be in compliance with legislation and must remain in compliance throughout the duration of the CEI. Alrighty, so what are some tips to drafting your proposal? Do not underestimate the quality of other applications. CEI is highly competitive. We often see more than 100 applications, all bidding for a finite amount of money. Be comprehensive but concise. Do not repeat information in your application. State the problem you are trying to solve and explain how the activity you are seeking funds for is the most appropriate method. Explain how your sampling program is testing your model in these greenfields areas. Detail the data processing and analysis techniques and link them to your model. Support your model with comprehensive research. This includes using existing models, data geology. Cross-sections are so important. Don't forget to add the scale, interpreted geology, proposed past drill holes. Make sure you locate them in plan view. If your application is a geophysical model, justify the depth and the location of your target and address why your chosen technique is appropriate for the depth and host rock. Applications will be judged on technical merit, so please ensure to include it. If your application is missing mandatory documents, it will not be evaluated. So if you have any concerns about what evidence you need to submit to meet these mandatory requirements, just contact us. There are some common failures we continue to see. So give yourself time to prepare your proposal. Ensure your layout is well thought out and flows. I cannot emphasize this enough. Explain how your project is collaborative. CEI is looking for innovation. Spend some time thinking about this and address it in your proposal. How is your project different from the 100 other submissions? Maps. They are a powerful tool. What's that saying? A picture is worth 1,000 words. Use them. Show in your proposed sampling locations, your proposed drill hole locations, geophysical survey lines, or your geochem sampling grid. Take the assessor to your EPM. Annotate your diagrams. Please do not just throw in images. Label it. Use a scale bar, a north arrow. Just locate it in space. The more you provide, the easier it is for the assessment panel. But please do not clog up your images. Discuss your expected outcomes and how they will expand exploration frontiers in Queensland. If you are applying for the full grant amount, the effort you put into your application needs to reflect this. I cannot overemphasize this. Please spend time on your application. Ensure all your documents are prepared. Make me excited about your project. Explain how your project is going to expand knowledge gaps in Queensland. Big picture stuff, not just postcard stamps. Alrighty, enough about CEI. I want to talk about another program another grant program that we have recently released, and it's called the Collaborative Development Program, or CDP. China currently provides 95% of all rare earth elements to the globe. This is not sustainable. The geological concentrations of essential metals and certain minerals in different countries provides a useful and powerful tool to play out geopolitical ambitions and creates a risk of imbalance and disruption between supply and demand. Therefore, we must diversify the supply chain. This is why the Queensland Government is committing $5 million in funding to help recover critical minerals from unconventional sources. The program is open now and will remain open as one round until June 2027, or until the funds have been extinguished, or until a date determined by the department. Applications for up to 100,000 will be considered. However, proposals for larger amounts will also be considered on a case-by-case basis. So, what is CDP? CDP is about recovering remaining mineralization found in mine waste. This program will offer merit-based funding for secondary prospectivity and metallurgical projects aimed at extracting critical minerals from remaining mineralization in mine waste. The focus is on creating new value streams of critical minerals, where new means where it wasn't produced at the proponent site or operation before. It would be a lost opportunity of this program to focus on things like extracting more zinc from low-grade ore, rather than extracting germanium from zinc ore that was historically not considered and remains in waste. So who is eligible? Some examples of potential applicants for funding under CDP, but not an exclusive list, are tenement holders in Queensland, operations of a mineral concentrator plant in Queensland, a holder or operator of waste tailings dam in Queensland, or a holder or operator of a coal-fired power station in Queensland. I strongly suggest, if you are interested in CDP, to get in touch with me and to start that conversation. So, what are some of the other funds that we have available that aren't being run by GSQ? I'm just going to touch on the $170 million Queensland Critical Minerals and Battery Technology Fund, which has been established to support Australian businesses to compete globally by enhancing the extraction and processing of critical minerals in Queensland, accelerating the development of battery technology and the production of precursor or advanced materials, and supporting Queensland and economic growth. This funding initiative is set to support programs from the mining stage to the development of processing facilities, including infrastructure projects. The funding is being delivered in two streams. So Stream A is a grant assistance program run by Queensland Treasury. This stream includes supporting feasibility studies, pilot projects, manufacturing capability, and early operational programs. Basically, it picks up where CEI drops off. Stream B is a venture and growth capital program run by the Queensland Investment Corporation. This stream is supporting growth stage businesses looking to scale up activity. For example, miners with a proven JOC compliant resource requiring support through early development stages to the development phase. This program is currently underway and accepting applications. I'm going to touch on Graphinex again because I just was at their site, and they have been successful in receiving one of these awards. So what they did is they took their successful CEI drill hole full of graphite, and now they are set to develop one of Australia's first fully integrated demonstration scale plants for processing graphite concentrate in Townsville. Another perfect example of how the government is helping explorers, and this fund in particular is set to help where the CEI funding now stopped. So I was able to visit their lab at the University of Queensland on Monday, where they've partnered, and they are actually testing, making and testing batteries using the graphite from that CEI hole. And this is a photo of the actual batteries that they are pressing and creating and running up there. Using that graphite from that hole. Queensland also has the potential to become a leading producer and exporter of critical minerals with the aim to become a pit to product state. With that goal, the Queensland Government is setting up the Queensland Resources Common User Facility. Located in Townsville, this hub is set to trial production processing for commercialization, enabling prospective miners to become producing mineral samples at scale. This facility will allow mining companies of all sizes to trial mineral processing techniques, demonstrate product production feasibility at scale, and provide the market with product samples to accelerate commercial development opportunities. This is expected to ease some of the issues junior miners face when trying to bring critical mineral projects online. The facility is intended to be operational for vanadium processing in 2025, with the capacity to expand over time to encompass processing other critical minerals like cobalt and rare earths. To encourage exploration for critical minerals, the Queensland Government is reducing the rent for exploration permits to $0 for 5 years. This has been calculated to be equivalent to $55 million worth of savings for the exploration community. I mean, that's pretty huge. All right, the last grant that I want to touch on is the $30 million award recently announced as part of the Mount Isa Mining Acceleration Program. This is incentivizing vanadium, copper, phosphate mining in the Northwest Mineral Province. This program expects to expedite mining projects with a focus on generating local jobs in only a matter of months. It is estimated that more than 2,500 jobs will be created over the next 5 years locally. This investment creates a broader demand for skills across the province. The recipients that were just announced for the Eva Copper Mine Project, the Paradise South Phosphate Mine, and VECO Critical Minerals Project. All right. I'm going to leave you with 3 things. Firstly, mineral exploration is getting harder and more expensive. However, the Queensland Government is strongly backing the resources industry and have a plethora of grant programs on offer. So if you have any questions on any of the funding initiatives I've been speaking on today, please get in touch. Secondly, our knowledge on mineral systems has never been better, including access to quality data like GSQ's open data portal. So please make sure you check out what pre-competitive data is available in your neck of the woods. And finally, if you hold an EPM in Queensland or are doing work in our state and we have not already met, please come up to me, introduce yourself, let's have a chat, and let's find out which one of these funding initiatives you might be eligible for. Thank you.
Just a simple one. With the Queensland Critical Minerals and Battery Technology Fund, that $170 million stream A, stream B, is there a recommended split of that 170 between the two, or is that something to ask somebody else?
Thanks, Mark. So just to restate the question with regards to the Queensland Critical Minerals and Battery Technology Fund, the $170 million, how is the fund, the amount of money split between stream A and stream B? To tell you the truth, I don't actually know the answer to that. Yes, but I can find out and get back to you.
Excellent. Thank you, Heather. At this point, we'd like to welcome to the stage our final presenter for today, David Purdy. David is the Principal Geoscientist at GSQ, and the title of today's talk is an overview of magmatism in critical metal in Queensland. Welcome, David.
It's not working. Thanks very much, Evan. Yeah, I feel like a bit of a fish out of water because this is actually an Eastern Queensland-based project. But anyway, I'm going to give you an overview of the peralkaline magmatic systems project and where my thinking is about these rocks at the moment. A bit of a warning, though, that there are still more questions than answers in this regard, but I guess that's what makes it more interesting. So first up, some important background. Peralkaline is just a classification for igneous rocks that have excess sodium and potassium relative to aluminium. And this gives rise to some interesting and different mineralogies. Peralkaline rocks are pretty common. They typically occur in post-orogenic settings, continental rifts, and also where mantle plumes interact with continental crust. And we're interested in these rocks because highly peralkaline and highly fractionated examples can be primary sources of critical metals, in particular the rare earth elements, the heavy rare earth elements in particular, but also other high field strength elements like zirconium and niobium. Peralkaline granites are also important starting materials for secondary deposits, like the iron absorption clay deposits that are very popular to explore for now. So in Australia, we have two advanced projects associated with peralkaline igneous rocks. There's Brockmans in Western Australia and also the Toongai deposit in New South Wales. But also in Queensland, we have significant enrichment associated with the Cenozoic Adrian rhyolite domes that occur in the southern Peak Range volcanics in central Queensland. And this has been well documented by Ross Chandler and Carl Spandler, and is being explored by NorthX. This is a really important area for our study because it forms a benchmark against which we compare all the other peralkaline or near peralkaline suites that we've been investigating in the project. So the existing scientific literature on these types of deposits is really interesting, and it basically outlines a mineral systems model. And it starts with an enriched or metasomatized subcontinental metal source. And the literature suggests that pre-enrichment of this source is a really important factor. And it's often linked to episodes of previous subduction, so recycling of oceanic crust. Very low degree melting of that source leads to accumulation of a mafic magma that's relatively enriched in alkalis, high field strength elements, and halogens. Then as these magmas evolve in the crust through very high degrees of fractional crystallization, the resulting magmas can become hyper-enriched in the incompatible elements, and that potentially includes critical metals. So fractionation is initially dominated by olivine and pyroxenes and also plagioclase, and this drives the magma composition to being more alkaline. Some models also involve low amounts of crustal assimilation through this process, but you don't really want too much of that because it'll push the magma away from peralkalinity towards being periluminous. And we know that maintaining high sodium in the system is really important because it keeps the melt depolymerized, and that allows fractional crystallization to continue to extreme levels. You also need to retain volatiles throughout the system to enhance solubility of alkalis and high field strength elements. And one really important factor is the timing of arfedzenite crystallization, the onset of arfedzenite crystallization, because this delays the exsolution of an aqueous phase and allows the high field strength elements to remain soluble in the melt. There's a suite of late stage processes that can lead to grade increases or changes in mineralogy that can be really important for mining and processing, making a deposit economic. But in this project, we've really been focused on finding signs of that primary enrichment. So with that background in mind, we turn our attention to the geology of Queensland, and fortunately, Eastern Queensland has seen episodes of continental rifting and plume magmatism since the late Triassic. So first step for us was to pull out all the igneous rocks that are late Triassic or younger in age, and you can see them on the map here. But we're focused on the felsic rocks. Focused on the felsic rocks, and they mainly occur in this area a bit north of Mackay, right down to the southern border ranges, and I've labelled some of the major units there. They generally fall into three age categories: a late Triassic group, a Cretaceous group that is divided into an early and late Cretaceous group, and also a Cenozoic group. So we dug into the existing data and information about all these rock units, and we compiled that up into an inventory, which is a published GSQ document. Here's a bit of a summary of those different age groupings. At this point, we kind of left the late Triassic behind because although there are some peralkaline units, including some extensive peralkaline granites, they were fairly well sampled, and we didn't see any critical metal enrichment amongst those, unlike the Cretaceous and Cenozoic. Turning to the geochemistry data we compiled from existing sources, you can see the most highly peralkaline samples are dominated by those from the Southern Peaks range, also some of the other Cenozoic units. There's also some Cretaceous units plotting up here, particularly the late Cretaceous. Similarly, with high field strength elements, here we have zirconium and total rare earth elements, dominated by samples from the Southern Peak Range. But based on this, the data and information we compiled, we thought there was pretty good potential for other Cenozoic units and Cretaceous units to be plotting up here with those. And so that's where the focus was as we took the project forward. Okay, moving on to some new results from the project now. We did focus on the Cretaceous and Cenozoic units, and you can see on the map here, all the yellow symbols on this map show the distribution of all our sample sites. So we covered a pretty big area in the field campaign, and as part of that, we've been able to update some of the geological mapping. A lot of the felsic Cenozoic units weren't mapped very accurately, so we updated the geological boundaries for a lot of those. Also, with the help of geochronology, we've been able to sort out what is Cenozoic versus early Cretaceous, late Cretaceous, and even Permian in some instances. One of the bigger mapping projects announced from this was updating the geology of the kaolin and proserpine mines to 100,000 sheet areas. And Josh Spence completed that work, and he's published the results of that in a really nice GSQ record as well. But this map figure here is an excerpt from his work, just showing the improvements he was able to make to the map sheet boundaries in that area. So it was really nice to finally have that finished off. We've also been doing more detailed work on specific units. For example, up around Nebo, we formally defined and described the Britton Range volcanics, so the felsic rocks up there. And we published a GSQ record that describes the sort of internal geology, volcanology, geochemistry, and also petrogenesis of those rocks. We're also writing up a paper at the moment on the Mount Hedlow trachyte and Elton Downs basalt. And we've also had Sam Platt, a QUT master's student, working on the Minerva Hills volcanics out here near Springsure. He's in the final stages of his master's, and he's done a lot of detailed work in that area. So in total, we ended up with around 400 new whole rock geochemical analyses, all completed using the same method, a lithium borate fusion. Joe, you happy with that? So using the same method, which is really important when we're looking at rare earth elements and accessory phases, as Joe pointed out. With Geoscience Australia, we completed a bunch of new shrimp, uranium, lead, zircon geochronology, a lot of new samarium, neodymium, and strontium isotopic analyses we completed with University of Adelaide. We also completed a drone magnetic survey in one area as well. But probably the most important aspect of the new results is, of course, the geochemistry. And you can see all of the data that we collected here, just coloured up by rock unit or suite of rock unit. And in the upper figure, which is a TAS diagram, you can see that we've got a lot of mafic rocks here as well. So we did try and sample the whole compositional spectrum of each unit, so we can understand petrogenesis. And in the lower plot of peralkalinity, you can see a lot of our samples are peralkaline or strongly peralkaline in composition. There's a lot of different units plotting up here in this field, but the main players in there are, of course, the Southern Peak Range volcanics. We sampled some more of those. There's a lot of peralkaline rocks in the Mount Hedlow trachyte, as I mentioned before. Parts of the Mount Ramsay trachyte and or all of the Mount Ramsay trachyte and parts of the Mount Cooper trachyte are peralkaline. A lot of the Glasshouse Mountains and Cenozoic units in the Noosa hinterland are peralkaline as well. And there's also a strongly peralkaline dike that crops out just near Kilcoy down southeast Queensland. So a lot of peralkaline units, but unfortunately we don't see huge amounts of high field strength element enrichment, apart from the Southern Peaks Range volcanics and parts of the Glasshouse Mountains. I should point out on these plots that the Peaks Range are a little bit overrepresented in that all of these triangular symbols are samples from one drill core, which is into Christmas Dome, drilled by Northex as part of a CEI. But we sampled a lot of other domes there, and they're all plotting up here as well. So overall, a bit disappointing, but the interesting question then becomes, why do we only see significant enrichment in the Southern Peak Range and Glasshouse Mountains, despite a lot of these units probably having a similar origin and including peralkaline or strongly peralkaline compositions? And it's a particularly interesting question when you consider that the Peak Range volcanics are part of this age progressive chain of so-called central volcanoes. So if we see enrichment here in the Southern Peaks Range, why don't we see it elsewhere along this chain or chains? And that's a question that I approached last year by directly comparing the Southern Peak Range with products of the preceding central volcano, the Nebo central volcano, Britain Range volcanics. And there are some major differences in volcanic expression, remembering that the Peak Range is essentially a series of large domes and cryptodomes, whereas the Nebo rocks are much more diverse and include a lot of pyroclastic material and also sedimentary units. There's also some significant differences in composition and, importantly, petrogenesis, where we suggested that the Nebo rocks had a much more complex petrogenesis rather than just straight fractional crystallization. And this is where the new isotopic data has become very interesting. So some really nice plots here of epsilon neodymium versus longitude in the upper plot and versus in placement age in the lower plot. The Nebo rocks are plot here in this purple symbol. Yep, still purple. You can see they have a very large range from around 1.5 up to 6. That's consistent with this suite having multiple sources or involving significant crustal assimilation and things like magma mingling. In comparison, the yellow symbols out here are from the Southern Peaks Range. They form a really tight group at around 3. That's consistent with those rocks being derived, or the full suite of those rocks being derived by fractional crystallization of a melt that originated from an enriched mantle source. So overall confirming very different origins for these two rock suites. But while we're looking at the isotopic data, what about these grey symbols out here? Just arrow them. They're essentially identical to the Southern Peaks Range. Well, those samples are from the Minerva Hills volcanics, which is associated with the Springsure Central Volcano here. So it's the next one in line from the Southern Peaks Range. It's about 100 kilometres further south and 1 million years younger. So the isotopic data is indicating they probably have the same origin, same source. And they're also occurring in essentially the same crustal setting. So why don't we see the same level of enrichment here associated with the Springsure area? Well, Sam's still working on these rocks, so I won't talk about them too much, but one obvious thing again is the diversity of volcanic facies we see. So in the Springsure area, there's everything from basaltic lava flows, scoriaceous breccias, scoria cones, right through to trachytic and rhyolitic domes, dikes, lavas, and also large volumes of pyroclastic and rework deposits. And they're all in place over a very short time interval. Why is this important? Well, in particular, the presence of large volumes of pyroclastic material, so the products of explosive eruptions, indicates a significant loss of volatiles from the system. If we remember back to that mineral systems model, volatiles are really important for keeping the melt depolymerized and allowing fractional crystallization to keep going to extreme levels. So there's something here in the Springsure area, a set of circumstances that's facilitated volatile exsolution and explosive eruption rather than retention and stewing and more subtle emplacement as domes and cryptodomes. So with that in mind, we started thinking, well, where else do we see the same styles of emplacement that we see in the Southern Peak Range? And one area that's very similar is between Rockhampton and Yeppoon, where the Mount Hedlow trachyte and Eltham Downs basalt crop out. So these are older, they're late Cretaceous in age, and they're part of a very limited suite of rocks of that age in eastern Queensland. But you can see in the panorama here, all these felsic domes, and a lot of those are surrounded by basaltic lava flows. So a very similar scenario, but probably on a slightly smaller scale to what we see in the Peak Range. So we've been out here and sampled these domes at multiple locations and also the mafic rocks. And we've done whole rock geochemistry on all those samples. We haven't done any petrogenetic modeling yet, but you can see from some of the geochemistry, these really nice linear trends. That's possibly consistent with extended fractional crystallization. Firstly, of a plagioclase dominated assemblage, and then an alkali feldspar dominated assemblage. A lot of these felsic rocks are also peralkaline, as I showed before, and most of them are adrian and or arfedsonite bearing as well. So up until this point, we're seeing some really good signs that we might see some high field strength element enrichment in this suite. But unfortunately, we don't, not compared to the Peaks range anyway. And you can see that on this plot here of total heavy rare earths versus zirconium. They're quite different each other. So again, a little bit disappointing, but the interesting question is, why is this? Well, if we go back to the neodymium isotopic data again, we can see the sample suite from Mount Hedlow. This is a basalt to rhyolite suite plotting in this area here. Has much higher epsilon neodymium values to the southern Peak Range. In fact, along with these other Cretaceous units, they're getting up close to the depleted mantle curve. So it's possible that the Mount Hedlow trachyte are missing that enriched or metasomatized mantle source right at the very start of the mineral system. And that's confirmed as well when we look at primitive mantle normalized trace element patterns. A little bit hard to see on the slide, the light yellow, but basically these are patterns for the most mafic rocks in these suites. And you can see that the data from the Peaks range, these curves up here, are much more enriched in a lot of elements relative to Mount Hedlow, samples from Mount Hedlow. Okay, so how about the Glasshouse Mountains? I wasn't going to do any work in this area because most of it's national park, which excludes it from exploration, but also makes it very hard to get in there and do anything. But because of the other geochemistry results, I was really keen to see what we would find here. So I went up there and sampled a bit earlier this year with Josh for a few days. So we can see from the panorama here, the landforms are very similar to what we see in the Peak Range. And indeed, all of these peaks through here are shallow level intrusions of some kind. A lot of them are peralkaline in composition. And as I showed before, and also on these plots, some of them show similar levels or even more higher levels of enrichment than what we see in the Peak Range. Similarly to the Peak Range, these rocks have been interpreted and modelled as the products of extensive fractional crystallization. So overall, despite being hundreds of kilometres apart and occurring in different crustal settings, these two areas are seeming very similar to each other. When we go back again and compare the neodymium isotopic compositions, here are the samples from the Glasshouse Mountains down here. They have much lower epsilon neodymium values than the Peak Range, similarly to all these units in the east. Very low values. So this is indicating potentially differences in the mantle source composition across this area. And although these samples from the Glasshouse Mountains are originating from different mantle source, they're still giving rise to high field strength element enrichment in places. So it makes you sort of question how important really is that mantle source composition. And as I mentioned at the start of the presentation, there is still more questions than answers, and I've listed off some of them that came to mind as I was making this presentation. Ultimately, though, we really want to know how to search for enriched bodies. And I guess the inevitable conclusion that I'm keep coming to is that the conditions and the set of circumstances that lead to emplacement and preservation of an enriched body are so specific that they almost can't be predicted. That's probably true for most mineral deposits, really. But we already know where to search in a regional sense with the existing geological mapping, geochemistry and regional geophysics that the survey has done over the last 150 plus years, and the addition of projects like what I'm working on here, we know where the peralkaline rocks generally occur. So we just need to get in there and sample as many of them as possible. And that's what I've been trying to do in this project. One more comment about prospectivity though, and that's about erosion level. And it's highlighted by this nice schematic from Marks and Markle. Here they show where agpiatic rocks occur in different areas. So I haven't mentioned the term agpiatic in the presentation yet, but that's referring to rocks that are so strongly peralkaline that they contain weird mineral assemblages that are really lucrative for rare earth elements, the types of things that we're really looking for in this project. And you can see, it might be a little small, but they used Tungai as an example just in here of an agpiatic laccolith or sill. And you might imagine that the domes in the Southern Peak Range are things like this feature that they're showing out here, maybe a different scale though. But what we'd really love to find is the mother lode down here, because that's where the really significant accumulations of agpiatic minerals are going to occur in layered intrusions, as is pretty well documented in the Kola Peninsula, Russia, and also Greenland, and to some extent Strange Lake in Canada as well. Unfortunately, though, this is going to be significantly deep. So perhaps the main problem we have in Queensland, in particular in the Southern Peaks Range, is that the erosion level isn't really low enough. As part of this project, I did want to try and investigate deeper levels of the the Peaks Range magmatic system using geophysics, but because of the geology, there's you've got the Anarchy metamorphics in there, you've got the Bowen Basin, and also the terrain. We couldn't really see a clear way of being able to use geophysics to image deeper levels of that system. We did attempt it in a different area though, up near Yatton, which is up to the northwest of Rockhampton. On the map here, you can see all these blue polygons are bodies that were mapped as Cenozoic felsic volcanics in an area that's mostly covered. We've since found out that a lot of these are actually early Cretaceous or late Cretaceous in age, but that doesn't really matter. The area had been explored for various commodities, including rare earth elements over the years, particularly down this area down here. When we were digging through that, we discovered this really nice ground magnetic survey, which is this detailed data you can see here. It's just sitting on the regional magnetics here. So it showed amazing detail in the subsurface there, and we wanted to fill that out to see what was lurking there. And so we acquired a drone magnetic survey. Here's the results of that survey here. It's not quite as detailed as the ground data, but you can see it's a major improvement on the regional data, and it does indicate quite a complex system of small magnetic and non-magnetic intrusions at depth in this area. So maybe this is the scale and the types of things that we need to be working on in different areas. Okay, that's the end of my presentation, except that I want to acknowledge the help that a lot of people, and some of them are listed here, have given at various stages of the project. So thanks to all of those people. Thank you.